Hi everybody, Mr. Jones here, and today I'm going to introduce you guys to equations, solving equations, kind of explaining what is an equation in algebra and how we go about solving it. So we're going to do a few examples here in a little while, but just focus on this one right here. I'm going to use this to explain what we're doing. Um, so the directions say solve for x, and this is probably something you guys would have done before. Maybe you would have seen it in even elementary school or middle school. So this shouldn't be brand new to you, but what we're doing here, right, with an equation, our goal is to do what the directions say, obviously, solve for x, right? But what does that mean? What are we actually doing when we solve for x? Well, right, in algebra, x is an unknown number. It's kind of it's called a variable, right? It's there's a number that would go there to complete this statement, but we don't know what it is yet. And so that's our big job with all these equations. It's kind of saying, hey, this is a math sentence, this is a statement, but there's just this unknown part of it, and it's our job to find what that unknown part is. Okay. And so just some important parts of equations before we get into it here. Um, all equations, right? It's right in the name. It almost has the full word equal, right? Equal, and all equations will have an equals sign, okay? And that's the big characteristic of it, okay? So when we look at an equation like this, 2x plus 5 equals 11, there's kind of two sides to that equation, okay? And the two sides are separated by that equal sign, okay? So what I like to do before I start any equation is I like to draw a line. Draw a line right down the middle of that equal sign, because what that does for me is that reminds me that there's two separate sides, right? And so this isn't just one long string of numbers, right? It is two separate sides to an equation, okay? So our big goal, where we're going, is we're going to try to figure out what is the value of x. What number would I put in there to make this true, to make 2 times some number plus 5 equals 11? What number would go in for x? So we're going to find that. And how we do that, okay, some of you guys might be really good at mental math and might be able to say, oh, 2 times this plus 5 equals 11, right? You might be able to think of what number goes there right away. And if you can, that's awesome, okay? I am going to show you a different way to do it, though, because as we get into more complex equations, it might not be that easy. Um, so what we're going to use are called inverse operations. Okay, I'm gonna write that to the side here. Okay, the word inverse is similar to the word reverse, right? And to reverse something means to kind of undo it or to kind of cancel it, right? Or to kind of go the other way. And so you guys can imagine, right? If we think of the math operations plus, minus, times, dividing, right? Those are the four basic ones, right? And so when we have these four inverse operations, okay, or the four operations, right? Addition and subtraction are opposites, right? If I give you $5, I'm adding $5 to your wealth. But then if I say, oh, give me that $5 back, that transaction kind of cancels each other out, right? And that's true of an equation too. Adding and subtracting cancel each other out. They kind of undo each other. And same with multiplication and division, okay? Those two are opposites of each other, and so we'd call them inverse operations, okay? And so let's do this. Let's try to figure out what this is saying. And again, our end goal, figuring out what the value of x is going to be, okay? So this is saying 2x plus 5 equals 11, okay? And so we see the plus sign. That's an operation that's in here, right? Plus 5, okay? But there's also this other number, 2x, right? And it's easy to think, okay, those are kind of lumped together, 2x, right? What it's not showing, and what's true, right? You see all these equations have that. 4x, negative 2x, negative 3x. All of those have kind of that number with x. And you might remember that's called the coefficient, okay? So what's happening there is it's kind of a hidden multiplication. That's being multiplied 2 times the x number, okay? And that's key. That's easy to forget, but that's key when we're first learning this, is to remember that's being multiplied, right? Okay, so let's solve this guy. So what do we do? What do we do here? Okay, Now, a key rule, okay, equations in math, there's a lot of rules that we have to keep track of, but the one big one for algebra, I call this even the golden rule of algebra, is what you do to one side, you have to also do to the other side of the equation. Those are called the properties of equality, okay? To make this remain a true math statement, we need to do the same thing to both sides. Because right now, these sides are in balance, okay? It's saying 2x plus 5 is equal to 11. You might not have seen one of these before, but imagine like a scale that has kind of two sides to it. Okay, right now these two sides are in balance of each other. Okay, so if I took away 5 or whatever from the one side without doing something to the other side, those would become out of balance. They would no longer be equal to each other. Okay, so for this to remain an equation with the two sides equal to each other, whatever I do to one side, I have to do the same thing to the other side. That is going to that's what keeps these two sides equal to each other. Okay, I hope that makes sense. That's one of the trickier things to understand. But yeah, just that's a rule to remember. What you do to one side, you have to do the same thing to the other side to keep those sides in balance. Okay, and so we're going to reverse what's happening to the x here. That's how we're going to get it. That's called getting x by itself. We're going to cancel out what is happening around the x, okay? So I look 2 times x plus 5 equals 11, okay? And so usually what we do first is we want to deal with any addition or subtraction because those are the simpler operations and they're going to be easier to cancel out than this multiplication. So we're going to save that for last, canceling out this 2. I want to cancel out this 5 because what that's going to do is get it one step closer to x being by itself. So I think, okay, plus 5. I want to reverse that or undo that. Okay, so what's the opposite of addition? Subtraction. That's the inverse operation there, right? So if I see plus 5 here, I'm going to do minus 5 to this one side first. Okay, so plus 5 and minus 5. Those two operations cancel each other out. Okay, and when I do that, so this is kind of step 1. Step 2 down here, what I'm going to write what's left after I do this. This 2 times x is all that's left over here. If I canceled this plus 5 by doing minus 5, all that's left is this term, 2x, okay? But again, every step of each problem, you have to think, okay, what I did over here, I also have to do to the other side, right? That's why it's helpful to draw that line. So if I did minus 5 here, I have to do the same exact thing over here, minus 5, okay? And what's going to result, right? 11 minus 5, those don't cancel each other out, right? But that's an actual little math operation that I can do. 11 minus 5 is going to be 6. 6 results from taking away 5 from that, okay? And so because I did the same thing to both sides, this is still an equation. It's still in balance, but I have just a little bit less on either side, okay? And so that's step 2. So right now, in this step right here, it might be a little bit easier for you to do the mental math with, right? Because this is saying 2 times some number equals 6. And so probably more of you are thinking, oh, I know what that is. 2 times this equals 6. But again, the other way to do that is to do inverse operations to the what's happening around the x. And so this is saying 2 times x equals 6. So if I want to cancel out this multiplication by 2, right, I need to do the opposite of multiplication, which is division, right? So if I divide both sides by 2, timesing by 2 and dividing by 2 are opposites, okay? So those cancel each other out. Great, that's what I want. But the x is all that's left over here, right? There's no other numbers. If I canceled out that 2, x is all that's left, and that's a good thing. That's what you want. You want to get the x by itself. That's our big goal, is to solve for x. Okay, but again, your rule with algebra, what I do to one side, I have to do to the other side. And so if I have 6 over here, I got to do the same thing. And over here, I divided by 2. So I got to divide by 2 over here as well. 6 divided by 2. And again, some kids aren't great with times tables, and that's totally fine. Just bust out your calculator. 6 divided by 2 is 3. There we go. Awesome. So x, the value of x is equal to 3, okay? And so again, what does that mean? Well, we found our unknown value, right? That's our big thing. It's kind of like putting together a puzzle. We found kind of the missing piece that is going in here for the x. We're saying it's 3. So what this is saying, now that I know the answer, is 2 times 3 plus 5 equals 11. No other number could you put in here to make this side equal 11 except for 3. And so that's what we're doing when we solve this out, okay?